The Welrod was designed for clandestine killing. Its purpose required near total acoustic suppression. The weapon originated under Special Operations Executive Authority. Development began during early Second World War years. SOE required weapons suitable for occupied territories. Conventional pistols produced unacceptable firing signatures. Suppression devices then available were mechanically unreliable. British engineers pursued integrated suppression architecture. The suppressor would form the receiver body. This eliminated external attachment tolerances. Design work occurred at Station 9 workshops. Station 9 specialized in covert weapon prototypes. Engineering leadership emphasized manufacturable simplicity. The Welrod used a tubular steel receiver. The tube served multiple structural functions, and it housed the suppressor and bolt assembly. The barrel was permanently integrated internally. No detachable muzzle component was required. This reduced mechanical junction failure points. The firing system used a manual bolt. It operated through a rotating rear handle. The bolt contained a fixed firing pin. Cartridge ignition occurred during bolt closure. This removed hammer and striker complexity. Eliminating recoil cycling reduced mechanical noise. The shooter manually extracted spent cases. No automatic ejection sound was produced. The suppressor contained stacked rubber wipes. These wipes sealed expanding propellant gases. Gas containment reduced muzzle blast dramatically. Each wipe degraded after repeated discharge. Durability was intentionally sacrificed for silence. Maintenance schedules required frequent wipe replacement, so operators carried spare wipe assemblies separately. Replacement required partial suppressor disassembly. The barrel length was deliberately minimal. Short length improved concealability in clothing. Accuracy requirements were limited to close range. The intended engagement distance was minimal. Most training emphasized contact proximity firing. The grip doubled as a magazine housing. Magazine insertion occurred through the handle base. This configuration minimized external protrusions. The magazine fed standard pistol cartridges. Early models chambered .32 ACP ammunition. Later variants used .380 ACP cartridges. Caliber selection balanced recoil and lethality. Subsonic velocity was operationally essential. Supersonic rounds defeated suppression performance. Ammunition procurement required special logistical channels. ASOE stockpiled appropriate subsonic loads. Manufacturing used standard steel tube stock. Machining tolerances were intentionally generous. Loose tolerances simplified wartime production. Surface finishing remained industrially unfinished. Cosmetic refinement held no operational value. Serial numbering followed restricted internal tracking. Weapons were not openly catalogued. Distribution records remained compartmentalized. Agents received minimal written documentation. Training occurred at isolated instruction facilities. Live fire exercises emphasized noise discipline. Students learned wipe degradation behavior. They recorded sound changes after repeated shots. Instructors enforced strict maintenance routines. Improper assembly risked catastrophic failure. Rubber wipe fragments could obstruct the bore, and obstructions caused pressure spikes during discharge. Safety briefings addressed this hazard directly. The bolt handle required deliberate operation. Partial closure produced misfires or ruptures. Agents practiced tactile confirmation procedures. The weapon lacked conventional iron sights. Sight radius was considered unnecessary. Engagement doctrine assumed point shooting. Night operations relied on physical proximity. Holster design prioritized concealment over access. Some models included detachable grips. This allowed alternate carry configurations. Grip panels were simple stamped components. Wood was rarely used for construction. Metal parts resisted moisture degradation. Field conditions demanded corrosion tolerance. Protective oiling was mandatory after missions. Neglect accelerated suppressor internal decay. Rubber wipes hardened in cold climates. Temperature affected suppression efficiency measurably. Testing documented seasonal performance variations. Cold weather increased audible discharge levels. Station 9 engineers evaluated alternate materials. Synthetic compounds were experimentally trialed. Most alternatives failed durability thresholds. Rubber remained the accepted compromise. The Welrod was never mass-issued. Production numbers remained comparatively small. It served specialized assassination assignments. Targets included occupation officials and collaborators. Operational reports were deliberately sparse. Field feedback emphasized reliability concerns. Suppression effectiveness remained highly praised. Agents reported extreme mechanical fragility. Dropped weapons frequently lost alignment. Suppressor tubes could deform under impact. Deformation compromised internal wipe spacing. Misalignment risked projectile instability. Engineering revisions attempted reinforcement. Additional weight was rejected immediately. Silence requirements overruled durability improvements. Transport containers included padded interiors. Storage cases reduced accidental deformation. Agents were instructed to avoid unnecessary handling. Cleaning tools were issued in compact kits. Kits contained rods and solvent vials. Improper cleaning damaged wipe integrity. Chemical exposure shortened wipe lifespan. Official manuals restricted solvent use strictly. Replacement wipes were treated as consumables. Supply officers tracked wipe distribution carefully. Loss of wipes reduced mission readiness. Some field units improvised replacements. Improvised wipes produced inconsistent suppression. Command discouraged unauthorized substitution strongly. The trigger mechanism was mechanically simple. It used a direct sear engagement system. Trigger pull weight remained deliberately heavy. A heavy pull reduced accidental discharge risk. Fine trigger control was unnecessary operationally. The safety catch was minimalistic. It blocked bolt movement mechanically. The safety lever was intentionally small. Large controls risked snagging during concealment. Grip ergonomics were secondary priorities. Function over comfort defined the design. Testing emphasized concealment metrics primarily. Sound signature measurement used enclosed ranges. Acoustic readings were compared against ambient noise. The Welrod approached background sound levels. This achievement justified design sacrifices. Accuracy testing occurred at short distances. 5-meter grouping met acceptance criteria. Extended range accuracy was irrelevant. Projectile stability remained acceptable within limits. Suppressor turbulence slightly affected trajectory. Engineers deemed the deviation acceptable. Production oversight remained highly secretive. Factories used civilian cover identities. Workers were compartmentalized by task. Few understood the complete assembly. Final assembly occurred in secure facilities. Quality control inspected wipe alignment precisely. Misaligned wipes caused projectile clipping. Clipping destroyed suppressor efficiency instantly. Rejected units were dismantled immediately. No defective weapons entered circulation. Shipping used unmarked wooden crates. Documentation used coded inventory language. Lost during transit triggered investigations. Recovered weapons were never publicly acknowledged. Postwar records remained classified for decades. Civilian awareness remained extremely limited. Later intelligence archives confirmed deployment. Surviving examples entered museum collections slowly. Many retained original wipe assemblies. These assemblies had chemically degraded. Conservation efforts avoided restoration. Restoration risked destroying historical evidence. Modern replicas use synthetic substitutes. Original acoustic performance is rarely replicated. Collectors value intact internal components. Documentation remains incomplete even today. Historians rely on fragmentary records. Engineering drawings were partially destroyed. Surviving schematics show iterative revisions. Each revision reduced manufacturing complexity. At late war production, simplified internal threading. Thread pitch changes accelerated assembly. Tool wear decreased after redesign. Material allocation influenced design decisions. High-grade steel was rationed heavily. Engineers substituted lower alloy variants. Performance degradation remained minimal. Corrosion resistance slightly declined. Field oiling compensated for material limits. The Welrod represented extreme specialization. It was unsuitable for general combat roles. Its lifespan was intentionally limited. Mission success outweighed long-term durability. Design philosophy rejected conventional standards. The weapon existed purely for balance. Every component reflected that priority. Further refinement addressed internal gas leakage. Engineers measured seal degradation patterns precisely. And wipe compression tolerances were recalculated repeatedly. Excess compression increased friction dangerously. Insufficient compression allowed gas escape. Calibration required specialized assembly jigs. Jigs ensured consistent wipe spacing. Spacing directly affected suppression longevity. Incorrect spacing reduced service life sharply. Assembly technicians received restricted training. Only cleared personnel handled wipe installation. Documentation avoided explicit suppressor terminology. Internal memos used coded engineering phrases. Security doctrine limited technical disclosure strictly. Inspection logs omitted operational descriptions. Auditors recorded only dimensional compliance. Dimensional checks used hardened steel gauges. Gauges verified bore concentricity alignment. Misalignment thresholds were extremely narrow. Rejected tubes were scrapped immediately. No rework procedures were authorized. Material fatigue studies followed extended firing. Repeated discharge weakened tube rigidity gradually. Engineers documented microfracture formation patterns. Cracks initiated near threaded interfaces. Thread stress concentrated during bolt rotation. Design revisions redistributed mechanical load. Later bolts used modified shoulder geometry. This reduced receiver stress accumulation. Testing confirmed extended structural lifespan. Lifespan remained short by military standards. Acceptable limits reflected operational priorities. The Welrod lacked rapid fire capability. Cooling requirements were operationally irrelevant. Heat buildup remained minimal per mission. Barrel metallurgy prioritized corrosion resistance. Accuracy retention was a secondary concern. Rifling twist rates were conservative. Stability favored heavier subsonic projectiles. Ammunition compatibility remained tightly controlled. Unauthorized rounds risked suppressor damage. Field agents signed accountability forms. Forms documented ammunition allocation precisely. Spent cases were often recovered deliberately. Recovery prevented forensic identification risks. Training emphasized evidence minimization procedures. Weapon surfaces lacked identifying markings. No manufacturer logos were present. Grip texture used simple stamped checkering. Checkering improved retention with gloves. Wet conditions reduced handling stability. Instruction manuals addressed moisture hazards. Condensation accumulated inside suppressor chambers. Moisture accelerated rubber decay. Dry storage was strongly recommended. Transport containers included desiccant packets. Desiccants required routine replacement cycles. Supply officers tracked packet distribution. Humidity monitoring formed part of inspections. Some deployments ignored storage guidance. Resulting failures were documented thoroughly. After-action reports cited suppression loss. Engineering teams analyzed returned weapons. Returned units revealed uneven wipe erosion. Erosion correlated with firing cadence. Rapid shots degraded wipes exponentially. Doctrine mandated deliberate firing intervals. Operators were briefed on cadence discipline. Improper cadence shortened operational lifespan. Field improvisation sometimes violated doctrine. Improvisation increased mechanical risk substantially. SOE leadership reinforced procedural compliance. Disciplinary notes referenced equipment misuse. A misuse threatened broader operational security. The Welrod required specialized cleaning rods. Standard rods damaged internal components. Issued rods used soft alloy tips. Tip material prevented wipe tearing. Cleaning strokes followed strict direction rules. Reverse motion risked internal snagging. Agents memorized maintenance sequences precisely. Maintenance errors voided operational readiness. Some agents carried duplicate weapons. Redundancy compensated for mechanical fragility. Procurement officers resisted redundancy requests. Resource scarcity limited duplication approval. Priority assignments received additional allocations. Allocation decisions followed classified criteria. The Welrod rarely entered conventional inventories. It remained outside standard armory systems. Armory officers often lacked awareness. A compartmentalization protected mission secrecy. Post-war evaluation boards reviewed effectiveness. Reports praised acoustic performance consistently. Durability criticism appeared in every summary. Engineers acknowledged intentional fragility. Fragility was considered an acceptable compromise. Alternative designs were proposed post-war. Most proposals increased mechanical complexity. Complexity conflicted with original doctrine. SOE doctrine favored mechanical minimalism. Minimalism reduced failure points conceptually. The Welrod embodied that philosophy completely. Later suppressed weapons adopted different approaches. Modern suppressors emphasize modular construction. The Welrod rejected modularity entirely. Integration defined its engineering identity. Integration prevented casual modification. An unauthorized modification risked catastrophic failure. Internal pressure calculations assumed factory tolerances. Field alteration invalidated those calculations. Engineering memoranda warned against experimentation. Despite warnings, experimentation occurred occasionally. Improvised alterations destroyed several units. Destroyed units were removed from records. Operational secrecy overrode accounting accuracy. Surviving archives reveal partial inventories. Exact production totals remain uncertain. Estimates vary across historical studies. Some records were deliberately purged. Security policy mandated document destruction. Destruction followed wartime intelligence protocols. Fragments survived in secondary archives. Researchers reconstructed timelines from fragments. Mechanical drawings surfaced decades later. Drawings confirmed early prototype variations. Prototype grips differed from final models. Early grips used detachable magazine wells. Later grips integrated the well permanently. Integration simplified assembly procedures. Simplification reduced machining hours significantly. Factory throughput increased after redesign. Throughput improvements met operational demand. Demand fluctuated with mission tempo. Low tempo periods reduced production runs. Equipment stockpiles remained intentionally limited. Excess stock increased exposure risk. Exposure risk threatened clandestine networks. Loss of a weapon triggered inquiries. Recovered weapons required immediate analysis. Analysis determined compromise probability. Compromise designs prompted procedural changes. No major redesign followed compromise fears. Confidence in secrecy remained high. The Welrod never entered public trials. Conventional forces never evaluated it formally. Its existence remained compartmental knowledge. Even Allied forces lacked full awareness. Joint operations rarely disclosed its presence. Handlers briefed only essential participants. Need-to-know doctrine governed communication strictly. This secrecy shaped historical understanding today. Many operational details remain classified indirectly. Indirect classification persists through missing records. Historians infer details from material evidence. Material evidence shows deliberate austerity. Every component reflects functional restraint. The weapon avoided decorative machining. Edges remained sharp and unfinished. Finish quality resembled workshop prototypes. Production never pursued cosmetic refinement. Cosmetics offered zero tactical value. Engineering focused exclusively on acoustics. The Welrod stands as an acoustic device. Lethality was a secondary characteristic. Silence defined its operational purpose. All engineering decisions served that aim. Postwar storage exposed material weaknesses. Rubber wipes degraded without controlled climate. Storage facilities lacked environmental regulation. Humidity accelerated internal corrosion formation. Corrosion attacked uncoated steel surfaces. Protective oils evaporated over time. Unmaintained units suffered rapid decay. Inventory inspections documented progressive deterioration. Quartermasters recommended periodic refurbishment cycles. Refurbishment authorization remained politically sensitive. Officials feared revealing classified inventories. Many units were sealed indefinitely. Sealed storage prevented routine maintenance. Mechanical condition declined predictably. Some suppressor tubes warped slightly. Warping altered internal wipe alignment. Misalignment reduced suppression efficiency drastically. Postwar engineers evaluated salvage potential. Salvage procedures required partial reconstruction. Reconstruction risked exposing technical secrets. Authorities rejected widespread refurbishment proposals. Instead, weapons were quietly retired. Retirement followed classified disposal protocols. Disposal avoided conventional demilitarization channels. Several units entered intelligence archives. Archival storage prioritized documentation preservation. Physical condition remained a secondary concern. Documentation included fragmented maintenance notes. Notes described wipe compression tolerances precisely. Tolerances remained difficult to reproduce. Modern replicas struggle with accuracy. Synthetic wipes behave differently under pressure. Original rubber composition remains uncertain. Chemical analysis reveals unstable compounds. Compounds degrade under laboratory conditions. Reconstruction attempts require approximation methods. Approximation alters acoustic characteristics measurably. Authentic sound signatures remain theoretical. Testing laboratories model historical estimates. Estimates rely on incomplete wartime data. Data gaps limit acoustic certainty. Collectors occasionally test preserved examples. Testing risks irreversible internal damage. Museums restrict live firing experiments. Conservation policy favors preservation. Preservation overrides experimental curiosity. Curators maintain strict handling procedures. Handling gloves prevent oil contamination. Human oils accelerate metal corrosion. Display cases control humidity carefully. Humidity stabilization prolongs material survival. Some institutions rotate display periods. Rotation reduces light exposure damage. Rubber wipes are light sensitive. Ultraviolet radiation accelerates cracking. Cracked wipes crumble under vibration. Curators document progressive deterioration photographically. Photographic records assist future study. Researchers analyze deterioration patterns. Patterns inform synthetic replacement research. Replacement research continues cautiously. Ethical debates surround restoration attempts. Restoration risks erasing historical authenticity. Authenticity holds priority in curation. The Welrod's rarity complicates experimentation. Few intact specimens remain operational. Most surviving units are incomplete. The missing components include internal wipes. Absent wipes prevent accurate reconstruction. Reproduction programs fill educational gaps. Educational replicas emphasize mechanical principles. They omit classified manufacturing nuances. Nuances remain speculative among historians. Archival silence obscures final revisions. Late war modifications remain undocumented. Some reports mention reinforcement inserts. Insert materials are not specified. Speculation suggests hardened steel sleeves. No surviving example confirms theory. Forensic analysis continues intermittently. Funding limits sustained investigation. Military museums prioritize larger artifacts. Small arms research receives limited budgets. Independent scholars conduct private studies. Private collections reveal occasional variants. Variant authenticity requires expert verification. Verification relies on machining signatures. Station 9 tooling left distinctive marks. Mark patterns aid identification. Counterfeit replicas lack those patterns. Market interest encourages fraudulent fabrication. Fraud complicates historical cataloguing. Catalogues require constant revision. Each discovery alters production estimates. Estimated totals fluctuate widely. Some historians argue minimal production. Others suggest moderate clandestine output. No consensus exists currently. The Welrod remains statistically elusive. Its secrecy succeeded operationally. Operational success hindered later analysis. Absence of records preserves mystique. Mystique complicates technical certainty. Researchers continue incremental reconstruction. Every fragment contributes marginal clarity. Engineering understanding remains incomplete. So the weapon resists definitive categorization. It occupies a niche classification. Neither pistol nor suppressor dominates identity. Integration blurs traditional taxonomy. Taxonomy challenges archival organization. Museums debate display classification. Some place it with espionage tools. Others classify it as small arms. Both categories remain partially accurate. This ambiguity reflects its purpose. Purpose dictated unconventional engineering. Conventional doctrine offered no template. Designers operated outside standard frameworks. That isolation produced unique solutions. Unique solutions carried inherent compromises. Compromises defined operational lifespan. Longevity was never a design goal. Mission completion remained the sole metric. Engineering evaluation followed that metric strictly. By that measure, the design succeeded.